Hey everyone, welcome to another session of CeerazzleDazzlePhysics. In today's session, we're talking about the models of the atom, guys. So put down today's title, it's going to be the models of the atom. And as usual, guys, make sure you like and subscribe to get my channel going, turn on notifications, because obviously I've got new videos dropping out every single Friday to help you with GCSE and A-level physics. Okay, let's get straight into it. So this will be the GCSE part of the course, and it's all about the models of the atom. So you probably know that the model of the atom that we have right now in terms of protons, neutrons, electrons, that wasn't the first model of the atom. There were previous models, and I'm going to walk you through what the different models are. So the first one is going to be this. Okay, so here is the first one. The Greek philosopher Democritus proposed that everything was made up of tiny, indivisible spheres, and this was the first model of the atom. Fun fact, the word atom comes from the word atomos, which means uncuttable. So this was the first model. Hopefully you've seen that. You've probably drawn particle diagrams before. This was the first model. It was round, spherical, and it was indivisible. This was the first idea behind the model of an atom. From there, guys, we had another model of the atom which was then proposed. So from that, we then had, okay, so the second model is going to be called the plum pudding model proposed by J.J. Thomson, guys. So this is the second model of the atom. So if we had the first one, now on to the second one. He proposed that atoms were like a giant positive charge. So here is my giant positive charge. I'm going to label it positive. There we go. It's positive charge. The whole thing is positive. And we have negative electrons embedded within it. So look, negative electrons are embedded within it. They are not free to move here. So we have negative electrons embedded on a positive sphere. There we go, guys. As you can see, negative electrons embedded on a positive body, guys. So they're not free to move. The electrons are not free to move and they're placed on there. Okay, and the reason why he gave it the name of the plum pudding model is because he thought he can try and make it more relatable to people. So he obviously, imagine that we make you a pudding. Okay, so here's my pudding. And inside we have plums embedded within it. The plums are here to represent the electrons, and obviously the pudding represents the giant positive charge. So that's the reason why it's called the plum pudding model. So the pudding represents the positive charge, there we go, which is obviously this round bit over here, the positive charge over here, and the plums are here to represent the electrons, guys. So the electrons are represented by the plums over here. And obviously the plums are embedded just like the electrons are embedded. They are not free to move. As you can see, they're not free to move. So that is the plum pudding model of the atom. From there, guys, we have the third model of the atom, which is going to be Rutherford's model of the atom. So Rutherford's model of the atom is different. As you can see right now, he proposed that the central part of the atom, yes, the bit where all the matter is contained, which is going to be called the nucleus over here, is a positive body. So he didn't say it was like the plum pudding. So the plum pudding is a positive charge and electrons embedded onto it. He said that the positive charge was right bang in the center of the atom. And obviously, he then proposed that there are negative electrons which are orbiting around the nucleus here. So the negative electrons are orbiting around over here. Key thing in this, a lot of kids forget that they think that neutrons are included in this model, but there are no neutrons at this stage. There are no neutrons at this stage. He just proposed that the nucleus was positive. There's no mention of neutrons at this point here. So this is Rutherford's model of the atom. Okay, so from here, surely this gives rise to the following problem. Surely the atom would simply collapse then, because you've got the positive charge here and electrons over here. Surely they would just move onto it, and surely that will cause the atom to collapse. Well, this gives rise to the next model of the atom, which is going to be called the Bohr's model of the atom. So from this model, we have another one, guys, which is going to be called the Bohr's model of the atom. And it is in Bohr's model of the atom, as you can see, where we have the protons and the neutrons inside the nucleus now, not just a positive charge, and we have electrons orbiting in energy levels. So these electrons, I know it looks like shells over here, the electrons are orbiting in energy levels. So electrons orbiting in discrete energy levels. The word discrete means fixed, of a fixed value, so discrete energy levels. They are staying in there and they are not free to move downwards. They are not free to move downwards. And obviously that stops the idea of the atom collapsing here. And that's going to be the final model of the atom. So as you can see, we've now reached the stage of the Bohr's model of the atom, which everyone knows from chemistry. Wonderful stuff. Now, obviously, guys, we're going to have a quick summary before we move on. So as you can see right now, we've covered all this today. So the first model is going to be tiny indivisible spheres. This was the first model of the atom. From there we moved on to the plum pudding model, in which we have a giant positive charge with negative electrons embedded. And from that we moved on to Rutherford's model, in which we have a nucleus where all the mass is concentrated and it has a positive charge. And electrons are orbiting it, guys. Electrons are orbiting it. And the final model of the atom is going to be the Bohr's model of the atom, in which we have protons and neutrons inside the nucleus, and the electrons are orbiting in fixed energy levels, guys. And this is the last model that we have right now. There are other models in A-level and maybe university, so you can obviously look out for them if you're going to go and study the subject. But for now, that's all that we're doing. Alright, and you might be thinking that I've brushed over a couple of bits. You are right. In my next video, I'll be talking about how we got the Rutherford's model of the atom, guys. It's a really cool experiment in which he fires alpha particles at a piece of gold foil. And that's it for another session of CeerazzleDazzlePhysics. Make sure you like and subscribe to keep my channel going. And joke of the day, why should you never trust atoms? Because they make up everything. Goodbye.